Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Free Energy Friday. It is Friday. It is December 5th, 2025. Welcome to the show. Christmas is around the corner. Happy Thanksgiving to our American buddies in the South. I hope you guys had a good Thanksgiving and a healthy one. And we're going to focus on the show tonight on more of the inventor stuff. I've been recently kind of really digging into Joseph Newman in the last week. So we're going to discuss him. And then Lulu's got some stuff about how the universe rotates around a 0 point. And she made a quick little sketch of her theories on that. And Nathan, I don't know, you have something you want to throw in there tonight?
First, I want to say hi to Ben. I haven't seen him in a while.
Yeah, he jumped in there earlier. He had to charge his headset. So he's back, and he's going to join us tonight in the discussions. Live chat is open. So any questions, comments for the panel tonight, please feel free to type it in the chat, and we'll try to answer your questions. So I guess we'll start with our little lady down there in the right corner, Lulu.
Hi Ben, how are you? Glad to see you that you're back and in action and everything. All right, so let me get back to let me start with my thing. Earlier today on Nathan, he was talking about his 0 point. So I was trying to make a comment on there, but I don't think people understood. It's called the Berry Center.
Hello, everybody.
Hi, Nate. Hi, Ben.
Hello, Ben.
Hey, Nathan. Hey, Lulu. Hey, Mike.
Hi, how are
you guys
you?
doing? Good to see everybody.
Good to see you.
Yeah, we're just starting with Lulu today, and we're just going to kind of do a round table of what we've been working on and researching, and we'll just take it from there. Sorry about that, Lulu.
No worries. But I wanted to go back to my Berry Center definition. You know, because okay, perfect. Okay, so our universe revolve, like its trajectory goes to a point that's a little bit before the sun, and it creates a like vacuum zone, a gravitational point, 0 point, like where all the energy, we don't see it, but it's called the Berry Center point. And our universe, all, you know, with all its planets, all rotation, follow that point in space. And so, you know, there is, I don't know what the science is, but it makes sense, you know, like if a lot of energy is put into one point, it creates a heavy, you know, like the heaviest part, like a black hole. And so it would be like the 0 point. But this thing looks like more like this. Last time I was trying to show it to you guys, you know, trying to explain like how the point works, but it looks like this, of course, with a little bit more things that are, you know, creating like a whirlpool, you know, in that center. But it does an up and it does a down. So you have like a wave function right there, and this thing, you know, like leads our solar system. It's like the coolest thing. So, you know, do search it. It's the legal or the definition to it on Wikipedia. It says in astronomy, the Berry Center is the center of mass of two or more bodies that orbit one another, and is the point where everything converges. You know, so look it up. I think this is very relevant in how we measure, space and time and energy and, our the speed, of our solar system.
So it's kind of like the yin and the yang, and it's swirling.
From what I read and I understood, it's not the yin and the yang, but rather of a point that our solar system follows. It's an invisible point, and it falls by because it's denser, and it's right before the sun's wherever the sun is moving. So I don't know. This is my theory. When we see a double sun or double horizon, maybe that's what we're seeing, that point, because it's a little bit, ahead of the sun. And so, I don't know, because we're always in constant motion. We're not, there's a lot of orbits that we do, and a lot of directions that, like where the magnetic field goes, we align with that. And so that point, maybe this is what we see sometimes as a double helix, double horizon. It's that point, it's the barycenter. Yeah.
Cool. Interesting.
I'm curious, is it a virtual point and it's a center of mass where there's two outside objects to it? Or is it an actual, like a black hole event, a horizon in the center?
Or how about even like a gyroscopic effect?
Yeah, well, that's what I mean. Is it like
I don't
the
know.
center of mass doesn't have to be an actual physical point? It just has to be where everything swirls around. You know what I mean?
I don't think this swirls around, like it swirls around it. The point is it follows it. It doesn't orbit around it. It's a point that the whole solar system like moves towards. And so it's like an indentation in the space of the fabric of space. And so it's like,
How about a curvature of space?
yeah, something like, I mean, if this is like, if we're going this way, in space, it creates like a dip, so the planets have to go, but it's a moving one. It's a constant moving one. That dip is always moving before, like the sun. And
So it's
the
like a
sun is having
dipole
to
with the
follow it.
planets acting like the electrons. Pretty
Yeah,
much.
it has to follow it, like I don't know how to explain it better than that. If let's say if it's tilting space time, and so the sun's having to move towards it. It's like if you're going down and a downhill, or it's like that. So it's forcing the sun to move towards it.
So an
Number four.
area of low potential, an area of high potential going to an area of low potential, you're saying?
Yeah, maybe, but that's how I understood it.
That's cool. Like a vortex. Just vortexing.
I mean,
Yeah.
I wonder, like, if that is, what is attracting things, in our solar system, because it's a point of energy, like if energy can come out, go in, energy can come out,
Mm-hmm.
yeah. So I
I'll
don't know
have to
why
look
it's not
into
talked to, like I don't know why they don't talk about it in physics. It's like I really had to dig for it, and the second that I started digging, with that term, all of a sudden within a few days there's like I don't know how many videos online about it. Like, man, like every time like I search something, like all of a sudden, like there's like I don't know, hundreds of sightings, like they start to cite the same, because I go back to it and I'm like, dude, I was like maybe one or two, or sometimes the first person on that. But like when I go back to reference it, I see like in such a short time, it feels like my browsing history, like somebody's following it and following that data tree, and they're using it,
Google does that.
maybe.
Google does it to recommend shoes for you. Anything that you look up,
Yeah.
it actually will bring you to those things and all the ads to you.
Yeah. Yeah, for sure. But Lulu, you're more into the astrophysics, not just physics, astrophysics.
Yeah. because it makes more sense to me. You know, when we talk about the electrical stuff, I love it, but I
But
like to
it's all related. It's all
exactly
related.
yeah. So
Um, like the electric universe, right? Trevor Constable. Yeah, I think Trevor Constable was pretty right on the money in his theories, and it all relates to astrophysics as
Well,
well. Right?
you don't have anything in the universe without electricity. I'm sorry, it doesn't work.
That's right.
there's
It's
the hydrogen frequency line. There's so many atoms of hydrogen in every, so many cubic
and what does
meters of
hydrogen
space.
produce? Hydrogen
Exactly.
creates electricity,
hmm They
right?
don't
It's
tell you about
fluid.
that, stuff,
That's
but
right.
yeah.
Hydrogen is one of the most fundamental noble gases in the universe, but it's also responsible for creating electricity, especially in a
Mm.
battery scenario. Yeah. Without the
You
hydrogen,
know,
you don't
like
get current.
they don't teach you this. And the other day I was actually searching it as well. The layers of atmosphere. The higher you go, the more of the less mass atoms there are, and a lot of these elements could be used as fuel right then and there, because there's it kind of filters itself out, like with density of the atoms on how. So like the higher you go, like you've got hydrogen, heliums, you've got the lighter elements. All of these could be like right then and there as you're going up, you could extract these things and use them as fuel, just by creating like a vacuum chamber in a rocket. Like it automatically will just suck it in without there's no effort, like it fills the tanks before on its way up. There's so many cool ideas, but people have to understand or know or want to know the science, so they know where to apply it or how to apply it or where it needs to be applied. You have to know the science a bit.
Yeah.
Yeah. All these gases and electricity and all these forces, magnetism, heavy side component, electrostatics, all this stuff, it makes our universe the way it works.
Absolutely.
And they're all interconnected with each other. One could be the creator of another, and vice versa. You know,
Well, I
so
mean, they say when somebody has a good idea, just the mere thought of it, others could think of it at the same time, because it goes into this shared field, of a potential. And so when people decide to pull that information or, start to search to prove you know, what they know, like all of a sudden our world, like you'd see two, three people doing it at the same time. It's like, how did they come up with that? It's just because we're all connected one way or another. They
Hmm.
say we're all about 6 degrees of, I don't know, like connections to each other. Six people, like it will take six people for that would connect two people that don't know each other globally. Just like you meet somebody and that somebody will know somebody, but like if you follow the chain, it would be like six people, and any
It's a
two people
common
could be connected.
phenomenon in the history of science. One inventor independently discovers something or comes up with a theory that's identical to somebody else at the same time,
Yeah.
or multiple people. And it's like the universe almost wants to will it into existence.
Yeah. It's like I think it would be like point to point. Like 1 point is one dimension, 2 point is 2 dimension, 3 point is 4 point, and so the more people you have an idea, the more it takes shape with depth. But like one person is just 1 point. Two people, it's a connection. Three people, it's a field of ideas. Four, you have stability, like, and so forth. It's
Well, that's a good
geometry.
point. You have to have multiple points to create multiple dimensions. So it's interesting analogy.
Yeah, same thing with people.
Mhm.
Yeah,
we're all connected to that too. Everybody
absolutely.
thinks that we're not connected to it, but we are.
It'd be interesting to find the harmonic between the people if they're the same.
Mhm.
Yeah, some
Yeah.
people probably resonate better with others.
Yeah.
It's interesting. Yeah, everybody has their own electromagnetic field that they're producing.
Well, the aura, right? People have
Mhm.
these
Mhm.
auras, I was watching a few videos actually this week with David Sarita, and he's working on these energy pendants that you wear, and they give off a little bit of voltage, but they resonate with your body, and they're really, really cool. Those some of them put out quite a bit of power. Well, not like hundreds of volts, but enough voltage to have interaction with your body. So he's been around forever too, David Sarita. Yeah.
It's pretty cool.
So Mike, any new interesting anomalies in the skies with your pyramid?
You know what? Since the cold weather has hit, I haven't really been able to get outside and do anything without freezing to death. Right? And batteries, don't really last too long in the cold. So I'm going to have to leave that for the spring. But I'm working on the new Renegade, and I'll be working on that project for the next few months because of the weather. It's going to be hard to get out there and get stuff done. But I got all the plans. I know what I got to do. So as soon as I get a couple of really good days, I can go out and get the build done. Right. So.
Ooh, a Renegade 2.0?
3.0.
3.0.
Yeah.
Nice.
Because it's gonna have a 2,000-watt inverter hooked up to it. The wheels can be spinning in a vacuum locked chamber, so there's gonna be very little air friction. It's also gonna be a maglev as well, so hopefully the spin on it will be very, very efficient. I'll get it up to a decent RPM and might be able to spin for hopefully a week on its own without any interference.
Yeah, especially with maglev bearings.
Yeah. So it's going to be
That's awesome.
maglev. It's going to be in the vacuum chamber. Yeah, it's going to have a couple of new features to it that all the other machines don't have. The piezoelectrics are still a big part of the machine. So I've been doing some research on piezoelectrics, and like it's the only solid state over unity device that I actually know is real, is a piezoelectric. Because you're getting more than double the power coming out when you put one impulse of high voltage to it. You're going to get more than double back, and it's very consistent. So yeah, another guy I've been really kind of backtracking on is Joseph Newman. I don't know if our panels really looked into Joseph Newman, but he refers how the electron moves around the inductor the same way as a gyroscope.
And you put the piezoelectric on the load, or the parallel with the load?
You basically short out the coil with the piezo.
Oh, you short out the coil. Okay.
You basically short out the coil using the piezo. So as soon as you release the power, you get the inductive reactance type scenario happen in the coil, the back spike or the back EMF, and that hits the piezo. So like most piezos, when you push put physical pressure on a piezo, it gives you power. There's other ones you bend, it'll give you power. I have the novel way of hitting it with power. If I hit it with power, does it give me something back? And lo and behold, it gave me double what I put in. And I'm like, whoa, what's going on?
Wow.
And that's where I realized I had something. And still, I'm looking online. Everybody's had a blind eye to it. Nobody's doing it. Still, nobody is doing it.
Yeah, that's crazy.
That's showing on YouTube. And there's a lot of people doing pulse motors on YouTube. Not one of them I've seen use a piezo transducer. Not one.
Well, I think that's just proof, Mike, that this really is the League of Extraordinary Inventors here. We got a bunch of remarkable people on the show.
See, the thing is, like some people have their way of thinking, and they don't look outside of the box and see what other people are doing to cross-reference what they're doing. You know what I mean? And they just don't do it. Like I had I think 2 people in the last 5 years that I've corresponded in emails where they've actually done what I've been working on. And they go, "Holy cow, man, it works." And I go, "What have I been trying to tell everybody for the last 5 years? It works." But most people don't do it.
My
It's like it's right there.
my jewel thief does it. I have a
Mm.
piezo hooked to it,
Yeah.
and it doubles it.
Yeah.
Yeah.
Interesting. How did you hook it up to your jewel thief, Nathan?
It was just my gravity flyer on the very top. It has the piezo. It basically goes through the. I'm going to say this. It's emitting the sound, right? Because
Mhm.
it's emitter and it takes in the sound. So I have a small toroid in there, and as soon as it comes into it, it gives it the frequency, and then you turn it off for a second, and it'll blast it.
Oh
Mhm.
wow.
Yeah,
I've
Interesting.
speaking of which, I was using my transducer one Saturday afternoon, and I was pulsing the hell out of it, putting a lot of just pulsing the crap out of the thing. I came back a week later. Thing was set. All the power's been off for an entire week. I went to grab it. Boom! I got friggin' zapped.
Oh
It had
wow. So it held.
it's yeah for a
It held
week.
the capacitance.
Oh my
week.
God, that's crazy, right? Yeah. How long does the capacitor usually hold a charge for?
They bleed out. Usually they bleed out over a day or whatever. This thing held it for a week, and
Wow.
friggin' I zapped myself the next weekend when I touched the damn thing.
Yeah, but
So
not all the like microwaves could last a lot longer. Like, like when they take the
well,
microwave apart to get that
it's,
magnet.
it's showing that you have the piezo transducer, and the one I have is like the ones that has the steel frame around it. So it charged, I guess, the electrostatic charge not only within the transducer itself, but also the steel frame. So the
Mm.
frame of it got charged.
Mm.
But the thing is, it didn't disappear. It held it. It held the capacitive value of the electrostatics in it.
Nothing
That's
was
very
grounding.
good to know when working with these.
Yeah, and I proved it not only by 1 week of a charge. I did it again because I'm saying, okay, we got to test this, how long it's going to hold it. So I did the same thing again. I didn't touch it for 2 weeks. Again, the second week came up. I grabbed it again. Boom, hit me again.
Oh wow. Did your hat fly off?
No, it was enough to get it. It's like when you touch the door handle and you get zapped. It was
Oh,
just
like yeah, static electricity.
yeah. It had the electrostatic charge embedded
Wow.
in it, and it wouldn't let go of it.
are you sure it's not in the piezo itself?
It
And not the
probably
frame?
was. It may be both. Maybe
Because
both.
you may have been in a charge cycle where it charged, and it did dissipate, so it stayed in there because that's
Yeah.
what crystal does.
Yeah, it shows that it holds that charge. Yeah.
Yeah, I've seen
Well-
that's interesting because I just watched a video recently on how certain kinds of like acrylic can do similar things where they hold like an electrostatic charge and then you can just put a bunch of pressure in one spot and just watch the lightning effect happen within the acrylic. It's really beautiful actually.
I saw
And
that.
this could-
I saw
and
that. They
this-
crack it
Mhm.
intentional for
Yeah.
I saw something like that.
Yeah, to release the charge. Oh, it's beautiful artwork too. It just produces this amazing pattern.
Now, this kind of goes back to the Floyd Sweet device. Bendini was talking about it, and he made this reference during his presentation that he suspected that the vacuum triode device was electrostatic in nature, almost like an electret.
What barium titanate, right? Is what your
Barium
piezo
titanate.
is.
Yeah, that's the ones I usually use.
Explain to me
So-
what electret is again.
An electret, it is, it can be made of a bunch of materials. I believe it's polyethylene is a good one. It holds electrostatic charge. So anything that is a dielectric plastic, and if you put certain elements into it, it holds that charge like an
Like beeswax.
electrostatic field. Beeswax is another one. Yeah. mixed up with is it polyethylene? Yeah,
It's
polyethylene.
you know the beanbag chairs, the little
Right.
balls. That's
Yeah.
polyethylene.
Yeah.
Oh, okay.
So it's a mixture of that, beeswax, and a couple other elements. And when it's curing, you hit it with about 20,000 volts, or some people use a lot higher than that. And after it's cured, that electrostatic charge holds and it doesn't go away.
Well, not necessarily. You have to put it in foil and let it sit for months, and
To cure
because
it.
it's got to stay that way. Yeah, but yeah.
Yeah. But, the idea of, the vacuum triode or the sweet device is kind of similar to almost a piezoelectric effect in there.
Okay, so it depends how you couple it, because some things spike voltage. So if you're spiking voltage, then think of it as the center of your capacitor. That would be how you want to set this thing up. That way it can do work back and forth to each other, because as it discharges to one, then it discharges to the other. Now you're doing work. Now you're in Floyd Suite. And there's another device that had two coils in it like this, one on each side, and the guy
Right.
was able to pull energy in the same way. Basically, he put up an antenna and then grounded it, and he's able to pull it, but it had to do with the mixture with that same element, that barium titanate, in the center of it, so that it could do work. And that was your oscillation in the system between the two, and then it would keep building up between the two coils themselves. Yeah, it's in that mixture. It's like bismuth when you put it in between two aluminum plates, right? It's going to do the same work. It's going to create work for you, so you don't have to do anything. It's the same thing as a meg.
It's like the Casimir effect, like how it creates the energy between two plates, like two electric plates or
But
two metal plates.
Yeah, but you're not losing the energy because it's going through the conductor material back and forth to each other. Yeah, you're right.
It's trapping the energy. Yeah. But kind of interesting how all these devices have similarities in the characteristics of the energy and the capacitive value, because a lot of people, when they're making coils, they don't really take into account the capacitive value of a coil. A coil does have capacitive value registered in henries, right? And even back then, this is like before, in Tesla's day, that wasn't really defined yet, so he was figuring all this stuff out before the actual terminology of henries and farads and all this stuff. This Tesla was prior to this, so he had to describe it in the best way he could describe it at that time, which most people had no freaking idea what he was talking about, right? So kind of interesting. I guess we'll move on to Ben, since we haven't seen Ben in forever. So we'll spend a few minutes with Ben and get us up to speed what he's been working on, and yeah.
Awesome. Yeah, we've had a lot of recent developments. Specifically trying to tune the coil, and trying to get the coil or the extra energy from the coil to be fed back into the battery. So we did some testing with the oscilloscope a couple days ago, and after drawing out the energy flow, the actual movement of energy from negative to positive, I kind of had a couple of realizations with the system that I'm working with now. And it's pretty incredible if it's actually what's going on. And so we got, the probe grounded across the negative and positive output. So we're monitoring the voltage of the output, and we're getting, on the oscilloscope, we're getting negative 168 volts, and then only positive 10 volts. So this makes complete sense why we're seeing a diminished brightness, and the full potential of the panel, 100% brightness, it's getting about 10% bright. So that explains a lot. And when I was drawing out the current flow from negative to positive, I kind of realized, oh shit, this is why they kind of like don't want you to learn this. Because when you draw out the flow like that, you kind of realize, oh, we're grounding out the systems in the wrong place in a lot of times. And what I discovered, or what's probably going on in the system, is I'm actually probably already, partially closing the loop and feeding energy back into the battery, most definitely, but it's not in the way I thought. So at the diode, you know how a diode works. You have the anode and the cathode, and in order for it to flow through the diode, you have to have a higher potential at the anode and a lower potential at the cathode. So it's kind of confusing when you're looking at the conventional flow in a circuit diagram or a simulator, and then you're trying to trace the negative. At least it confused me until I had to kind of look at it for a minute. And I realized the diode is actually splitting. The diode is splitting the back and forward EMF. So originally I thought, because we were getting, a resonant pulsed waveform where, you have two waveforms, the back and the forward, kind of chasing each other. I thought that was going into the load and powering the load. No, the diode is splitting that off and feeding the energy back into the path of least resistance, which is the negative terminal, because I have, early in my experiments, decided it was more efficient to disconnect the input negative and just connect the ground via the negative terminal on the output power rail. And I found that slows down the battery decay. And this kind of matches up with the theory that if this is true, and it makes logical sense when you look at the circuit. We can look at it in a minute if you want to, but the positive doesn't have any clear return path to the battery. It's the negative that's returning to the battery. And if that's true, then it has to be the synergy between the forward and the backward, creating that bridge, back to the creating the circuit, closing the circuit, as it were. But it's closing it with the back. So it's my theory that we could be, preserving the dipole instead of charging the battery. So I don't think we're really charging the battery while we're running the system, but we might be slowing discharge by kind of feeding that dipole with the back EMF. And this is really interesting. And we had another really great breakthrough today, kind of proving that this, the rodent coil, the APA coils, they really do some remarkable things, because we had something similar happen in a different setup, the stereo amp setup. If you've remember my Wattman reduction experiment, we've gotten that tune to reduce by 33 watts, which is extraordinary, by spinning a neodymium sphere in the center of the coil, powered by a stereo amp at about 115, 120 hertz. And this reduces the input requirement, but we were using the wall and a power supply. Tonight, I decided to hook up a 12-volt battery to the system, and what we saw was incredible. So the resting voltage, the stable level voltage without anything hooked up on the battery, was about 12.66 volts. And then we tested the baseline. We turned on the stereo amp, which is, anywhere from 12 to 18 volts max. We turn that on, and then we just turn the frequency up, because that's going to require more draw from the battery to maintain the frequency. So we turned it up to 70 hertz, and it was drawing from the battery. The battery went down immediately to 12.45 volts. And then we put the frequency back down, and then we spun the sphere in the center, and we tuned it back up to 70 hertz. And this voltage just jumped back up to 12.53 volts, and it slowly started climbing to 12.55 volts. And I was like, holy crap. Like that. And we let it ran for, I didn't want to run it too long because I don't have an ozone detector, just in case, but we let it run for a good, like 5-10 minutes. And it was just slowly climbing. it was not degrading at all. I was like, what the heck? It was incredible.
And that's exactly what the Renegade does. It
Oh,
basically
wow.
removes the demand for any current.
Yeah.
This is what Joe. This goes back to Joseph Newman. He
Oh,
says
wow.
you don't need current as long as you got the proper inductor and you pulse that coil at a high voltage. You don't need input current. He was using dead 9-volt batteries. They only had like 7 volts per battery with like less than 10 milliamps of current coming out of those dead batteries. And all he did was daisy chain them all together. He had 84 of them. He got it up to like 400 volts, and he was able to move a rotor that weighed 1,800 pounds.
Wow.
Provided you have a large enough inductor. It says the generating power is done in the coil, not from the battery power.
Yeah,
Battery
from the
power,
electromagnetic field.
right, is creating the
Wow.
gyroscopic spin of the electrons around the inductor. So if you have a very large inductor, like he says, to get my effect, you need about 200 pounds of copper wire. As soon as you exceed that 200 pounds, you'll see the magic happen. And this is everybody who builds the Newman motor, they're going, where's this excess power? I don't see it. Meanwhile, they got, maybe 800 grams of copper. You're not going to get the effect. You need 200 pounds of coil. Doesn't matter how many windings. Windings are irrelevant. It's mass. If you have enough mass in that coil, you hit it with 400 volts, you're going to get a shitload of power coming back, way exceeding the input voltage.
Does the motor have a sound? Sorry, Nathan.
Well, the commutator makes noise.
Okay.
The arcing, you get the blue spark. So he was finding it was burning up commutator. So he fixed that problem by just adding in a microwave oven capacitor and hooked that up to the inductor. So every time the inductor was spinning on the commutator, it would hit that spot and get that spark. That capacitor from the microwave oven would absorb that power. So his commutator wouldn't, self-destruct, basically. That's how he solved that problem. But a lot of people have built the Newman motor, and I've seen a lot of videos of guys doing the Newman motor. It's not that they haven't built the motor correctly. It's the mass of the coil is wrong. You need 200 pounds. He says it in his that's a lot of money, yes. But we're talking about a motor that was made 45 years ago. Right? So it was a lot cheaper back then.
Yeah.
But in a practical aspect, is it really practical to make a motor like that now? Probably not. But it doesn't say that his theory didn't work.
Okay. I have a question for Ben. When you turned it on the first time, and then you came back and turned it on, were you conditioning the battery?
Say that again?
You said you turned on your system and it wasn't spiking the voltage. Matter of fact, it dropped it. Then you came back again, turned it on, and it spiked the voltage going back into the battery. Were you conditioning the battery to take the energy the way you wanted to give it to it?
I think that's exactly the way that you can think about what was happening. I think it was conditioning the battery. I can't say for certain because it was only one test that we did. But we'll run it a few more times and see.
Well, I can add to that. Bandini talks about this. If you're using a battery that is negatively charged, then that back spike that you're getting that's giving you that effect won't harm the battery. But if the battery you're using was charged on a conventional charger and it's the hot electricity, okay, eventually that battery you're using is going to die. So what you have to do is you have to condition that battery to take a negative voltage. And Bandini
we can do that with the
Bandini
SSG too. Yeah. So we can do that and try that too. That's a good idea.
Yeah, because if you have a regular standard battery, taking that back spike in the negative
Mhm.
or the cold spike, eventually it's going to destroy the battery.
Right.
You're going to wreck the battery. And
So
Bedini,
I
Bedini
think
also said there was a
no,
hole in the plates. I'm
yeah,
sorry,
Mhm.
it'll
Ben.
burn a hole through it.
No, I mean,
Oh
but there's
wow.
holes in the plates. But because you're using electricity and it's the back EMF, it puts energy and fills the hole with energy. So it if you had like a round toroid, it would be filling up the inside with energy right there, and that's how
Mm.
he's back conditioning it inside the battery.
Okay.
Sorry.
I mean, I have a question. In theory, like, would an electric panel, like a person's electric panel, and let's say they're neighbors, could one run off of the hot and one off of the cold? Because it's in the, on the same line.
I
Well,
mean, what I've experienced is loads really like, I don't know, at least from my experience with this system, the load really does good with positive energy. Maybe it's just designed there. These, LED panels are designed to work good with the forward, but yeah, like I think a lot of our components are designed to work good with the forward EMF and not the negative energy. But what you can do is, I guess, branch them off. Use them together and then branch them off for different purposes.
I
So
mean, I'm trying to understand, like, how, like, what are the
yeah,
possibilities, like, yeah, go
Mhm.
ahead, Nathan.
bringing the energy into your house is AC, so it's not cold and hot on there in that way. So it won't work that way. We're talking about the DC coming from a battery is a little bit different. Okay, even from the actual wall DC that you would put in and put it into a converter and stuff, it's a chemical process that you're going through that is making the circuit function better. I wanted to say this to Ben. I don't know if you ever heard of a snubber circuit. It's basically a diode that crosses over and goes back over to your base.
Mhm.
Okay, so what it's supposed to do is any voltage spikes that comes in, it'll take it from, I think it's your collector, straight over to your base and
Mm.
refeed the system. Okay,
Oh,
so
I'll
it
have to check
adds,
that out.
yeah, it adds it in. So it's made for a testicle of voltage overload. When you get too much energy, it comes back down and it goes back into your circuit. But then instead of going back and hitting your circuit and blowing it up, it'll
Mhm.
transfer the energy right back over to the base and continue to run it. You can also put it into a cap. That's your snubber circuit. So that's how you do capture. Okay.
So
But
it's just a high-speed diode that I can place between the collector and the base.
you could just do it with a regular diode. Gerald does it with a
Regular diode.
regular diode,
Mhm.
14007, I think it is.
Okay, I
And
got one.
he's able to push it over, and then he puts it right back into the base because it also holds the frequency of what you just did. So it starts to work as your frequency going into the system. So now you can reduce the power that comes from your frequency generator that goes in because it's already getting extra energy. So you can reduce how much power you're putting into the system by still getting the same amount. Or you can drive it into a cap bank, okay? And
Mhm.
with negative energy, you got to remember you have to have that draw, so that little light. You know what I mean? And then
Right.
if you really want to get it excited, then just remember go back to Gerald's circuit where he put that what is it called, neon over the top
Mhm.
between his collector and emitter. What it does is it's acting as like a diode, so it'll set off and give you heat in the system in that spot, but never back to the coil. It'll never bring heat back to your coil, so it keeps it cold while crossing over it. So just a couple ideas out there. Gerald had it up on his page for his circuit. Just check it out and see, and you'll see the connections. And
Well, I
I
think
think it
that's
might help.
brilliant, especially with the diode placement.
Mhm.
I never thought of that, refeeding the extra, because there's got to be extra that's not being used or just being absorbed by the diode that's facing the load. So I'm assuming that you're right, that connecting the collector to the base in some way is going to prove more efficient, for sure. I almost guarantee it. So I definitely
just diode your frequency generator so it doesn't go back into it.
So that's incredible. Yeah, that's great advice. We'll definitely try that.
Right on.
Sorry, I'm eating ice cream here. Hey, Philip.
Hey, Phil, how you doing?
Hey,
Go on,
what's
Phil.
cracking?
Hey,
I
Phil.
was at the. I've been betraying you guys. I was at the Demystify Science. Demystify Science show, but I just waited for nothing again. So that's the last time
I feel so used.
Hey, tonight, man. The show is historical. I'm not lying to you. It's historical. I wanted to show it last week, but everybody was sick or busy or was partying like crazy, so there was no show. And yeah, now I can. I'm all prepared. I can show it. It's really historical. I'm not lying, man. I've been saying that a couple of times, but now it's true.
Yeah, we'll let Ben finish up here, and then after that, we'll switch over to you.
Okay. So sorry to interrupt, Ben.
Oh no, you're good. So basically, to summarize, I think this realization is kind of that the synthetic AC is more of like a carrier of those electrons back to source, where the positive really doesn't have any logical way to go back to the battery. It just kind of dissipates into the load, which is kind of insane when you think about it. Like, that's not how we're taught electronics work, you know? So I don't know. It's mind blowing, and it goes back.
That makes sense, because if you're throwing all this electrical power and current into the coil, what's it going to do? It's just going to create heat, right?
Mm-hmm.
So
right.
if you hit it with voltage with no current, the coil
My
doesn't
live
heat
stream
up.
just ended again. This is like the 6th time today.
Wow.
Just randomly just quit. I'm not having a bandwidth issue. I didn't hit the end
It's a
stream.
solar flare.
It's a solar. No,
flare.
it's some asshole with a button. You jackass. Go bother somebody else. Seriously.
Oh, that's great.
Maybe that's
Ben's
why it's a
neighbors
good.
messing with him.
Maybe that's why it's a good idea to like stream multiple people at the same time, where
Oh,
if one
definitely.
drops, that way still the information doesn't get lost.
Definitely.
Yeah.
Redundancy, right?
Yeah.
Exactly. No, this is a brilliant idea, because I'm still live, so you can kiss my ass.
Both
I'm
teams.
sorry for
Pity
the
the
profanity,
fool.
folks. This really grinds my gears.
I love it.
Yeah, I was thinking it, but I don't want to say it like that. But
Oh man.
So, Ben, are you done, or should we go on with Philip here? Or
Ben should have mic dropped and left.
Yeah. Ben went to
drop the mic?
pour in some whiskey in his glass.
Yeah, he's just like, I'm done. Yeah.
Yeah, I just want to summarize by saying that we're learning really we're learning a lot of different avenues on how to increase efficiency of this Joule Thief. I've got a couple of different circuits I've been working on too. Pre-driver circuit, where you have a MOSFET and a small transistor driving that. So, we got a lot of progress being made. That's all.
Ben, you want to check out Laser Saber. He did a lot on the Joule Thief.
Okay.
This stuff was done years ago, like 15, 16 years ago. Like, you got to watch some of his stuff. Laser Saber was on top of a lot of really cool stuff.
He's really good at a lot of things.
Yeah, I think he's an engineer. I'm pretty sure he's an engineer by trade. But but the stuff he comes up with, he just knocks it out of the park. Like, he's one of the very few guys out there I go back and reference on certain things like Stubblefield or some of the Jewel Thief circuits he's worked on and electrostatic motors, and so that's the guy to go to. So yeah, look into it. He did one circuit. It was a JBR circuit in a Jewel Thief. It's kind of like a modified Jewel Thief circuit.
Mhm.
You might
I'm
want to
interested
check
in
that
any
out.
kind of modifications that people have found because there's a lot of different
Yeah.
variations out there, and people, they're crafty. They'll find different ways of doing things more efficient, and you guys are like that. So like I like coming on this show and talking shop with you guys because you guys give me a lot of good ideas. I know like Nathan was the one who was telling me to follow the current from the negative to the positive before a while ago. And that's probably the most useful advice I've had doing exploring different theories on how this thing is working and why it's doing what it's doing.
I would say check out Gerald's stuff because he pulls the negative to the positive in all of his coils,
Mm-hmm.
and he uses the battery. Probably the best reference you could do is check out his circuit and look what he does, because he's definitely got something going on there. And when he tells you he can turn it off his system and it continues to run for a little bit, it means that he's getting it colder than the environment itself.
Yeah, it's an
which means-
endothermic reaction. And
There
I'm using the transistor he suggested to me. It's still to this
there you
day,
go.
it's the one that I use because it's the most efficient.
Yeah, try that, because if you can control the heat in your system, you control your system.
Mm.
Yeah, and you get it keep running. That's why he did the diode that goes over so that it can rerun the frequency through the system. If you follow what I'm saying, it runs it itself and it creates resonance. If you have two of them in resonance, same frequency, you're getting a little extra there. You're keeping it cold. You know what I mean? And that's the whole process of getting over unity. It has to be in resonance and cold.
Mm-hmm. Interesting. Yeah, I'll check it out.
Cool. All right, Mr. Phillip, you're up.
Yeah. Yo. So yeah, I'm just gonna share my screen here. Share screen. Blah blah. Oh, where's my? Okay, there you go. All right. So here is the free fall experiment. The Galileo and Newton's its equivalence principle that was saying that any object of different mass will follow the same acceleration on the Earth, on the surface of the Earth, and which Einstein based his theory on as also. So I'm proving it here that it's all garbage, and the spine of physics is all garbage. That's one of the most important laws in physics, fundamental laws in physics, and it turns out to be garbage. So
I love how
yeah.
you say that.
Yeah,
It's so funny.
yeah. Look at that. The here on I'm using electromagnets here to hold the balls against gravity. I'm using 3 amps in a bobbin coil to hold the magnetic neodymium ball of 66 gram, and this one is on the left, or the red ball, the red circle is, and on the right is a chrome steel ball of 67 grams. And I'm using.
You got balls of steel up there?
Yeah, exactly. Yeah, balls of steel. One is magnetic though, so.
Oh, one is then the other one isn't though. You said.
Yeah. So I'm attracting other magnets.
So we're gonna see your balls drop in a minute, right?
Exactly.
Hey, this is a respectable show here.
Sorry.
It's historical.
I started something. I'm sorry. I'm sorry, Phil. Go ahead.
It's historical body part show. So on the right, I'm using a ferrite core to hold the chrome steel ball because the ferrite core is because when I'm using an iron core, the ball sometimes still sticks to it for a moment of time when I cut off the current. And the ferrite core, there's less magnetance, you call it, to hold. The ball will most likely fall immediately when the current is cut. So anyway, here we go. So it's all in slow motion here. You can see the red ball is accelerating faster already. They were launching exactly at the same time, and the red ball is accelerating much faster than the turquoise or blue ball. And there you go. You can see on the right the discrepancy here. The discrepancy of the difference in acceleration of the two balls. So these are huge difference. You can see the magnetic ball is falling much faster than the chrome steel ball, and yeah, it's not even close, man. It's like it's not even close. There's a large discrepancy. I mean, no wonder the mainstream is trying to bury the findings of the Lockheed Martin guy. I always forget his name. Um, but yeah, man, that's what I'm saying. That's what I want to show. And here is the graphic here. You can see the difference in acceleration. It's consistent with my predictions. I did all the maths here. I did all the maths, and it's consistent with my prediction that there's going to be a difference of 0.022 meters per second squared, and I get something very close, very similar here. The delta here, it's 0.003. So it's almost the same thing. So I need to I've been repeating the experiment many times, not just one time, and I get very I'm within the uncertainty for sure. So yeah, man, it's like it's historical, man. You guys are made the history.
Yeah, this is a really historic night, Phil. You're absolutely right. There's a lot going on.
Yeah, so the spine of mainstream science, it's all garbage, man. So here's evidence. I've been telling my mailing list, Curtis Horn, Jack Sarfati, Eric Weinstein, all that garbage, and they don't say anything,
I go back to the picture that Nathan made of you with the middle finger. You just give your middle finger to mainstream science.
Yeah, because you always come back to that conclusion,
They last APAC they were giving credit to somebody that's doing this experiment other than you.
Which experiment?
The drop, the two magnet and the steel ball drop.
The
Yeah,
free fall?
yeah, they were
That's
giving
crazy.
Yeah,
Are
like
you
if you
kidding
go,
me?
no, I'm not. If you go back and watch it, like the live one, I think somewhere in the middle they were talking about it, and they're like, congratulating somebody about it. Yeah.
Are you serious? Well, I gotta watch that shit.
No.
That's shady. Yeah, no, I mean, I asked him if he wanted me to have me on his show, and he was interested at first, and he asked me what my system was, and I told him, and I haven't heard back from him. So.
Do you know how much of a greater idea this would be if they would just like attribute to the rightful person, Like
Yeah, it's completely
yeah.
like they take credit for other people's work, and I'm handling they're moderating their stupid chat. Why don't Tim moderate his own chat? I'm getting tired of this. He can do the boring part. I'll do the fun part.
But they don't
We'll
understand it's
flip
like
the roles.
it's like the whole YouTube and podcasts, and this is all integrated information. There is a place where all this information is collected, and it's time stamped on who said what, each word. I mean, this is what AI is for, let's statistics to see, when a new word comes out, or a new definition online, like where everybody can search this. This is what AI does, and they don't understand. They could continue to play this game, but real AI knows the real, author to things.
Yeah,
You're
They
not
but
does.
wrong. You're not wrong.
I already submitted a paper for peer review, and I've got evidence with my YouTube videos. It's all dated, so I've got evidence. I'm the first one, to say it
That's good. You want
to
proof
come.
that you were the original
Yeah,
author.
exactly. I got evidence, and the closer to the date they are, the creepier it makes them. Because if I release something at the end of November and the beginning of December, they come up with exactly the same thing. That proves that they're trying to copy whatever I'm doing. You know what I mean? So that makes them even creepier.
Yeah, that's kind of
Yeah, you
unfortunate.
damn creeps.
We have a guest on here, Dr. Yu. Is it? Did I pronounce that correctly?
Yes, that's correct.
Yeah,
Thank
welcome to the show. I remember seeing you at Tesla Tech with Bernie. Bernie has just joined us as well.
Oh,
Okay.
hey.
Hello, Dr. Yu.
Hey,
Oh,
Bernie.
hey, Bernie.
Hi, doctor.
Sorry about it. I did not expect this late meeting. But thank you for
Well,
inviting.
thank you for joining.
It's great.
No,
Awesome.
no, just interrupt, Lulu. I'm just gonna scoop out and trace that APEC video from last week. You were saying just to compare what they were doing.
Okay.
Yeah, it's in the private chat, Lulu, if you want to click on the link after the show or whatever. But yeah, let's talk with Dr. Yu. And yeah, welcome again to the show.
Oh, thank you. So I just got a notice. I'm not exactly for sure what kind of topic you are discussing, but I'm willing to contribute if any questions.
Well, we've been talking a lot about electromagnetics and the Joule thief circuit, and yeah, it's right up your alley.
Oh, okay. So if you have any specific questions about it.
Well, there was an inventor back in the early 80s. He actually was denied his patent, Joseph Newman. And he discovered that the way the electrons flow around the inductor is very much gyroscopic.
Okay.
Would you agree with that statement?
Oh, actually, I believe I discussed this one on Bernie's show. Actually, what I discovered is the so-called electron is a magnetic particle. It's not like a called a negative charged particle. So electricity is not a flow of particles. So I do not believe electron flows anywhere inside of conducting material conductor. So what really happens is every single atoms in the conductor, they are magnetic particles. They connected as a magnetic combined connected. So like an elastic medium. So what the electricity is actually oscillation. So circular oscillation due to the generator, right? Generator, you have a relative motion. So create a local excitation. So all the coils inside of the motor, inside the generator, so because of the orientation changing relative to a magnetic field, so create the particles oscillating, and then the oscillation propagates through this called the elastic medium. So propagates. So you mentioned about the drift of electron. Bernie mentioned about take what is it for hours, right? Drift on inches or something like garden snake, very slow. So what I find is actually a particle inside of conducting material does not drift, no particle we call it emit from any atoms. It was actually atoms oscillation, natural called resonance vibration. I hope that give you some sense. So if you think about it, if you doubt it, right? Think about how alternating electricity works. You know, we call the direct current supposed to flow in one direction, right? At 70% of speed of light. Okay, so now you think about alternating electricity. So electricity, the direction of flow, changing direction 120 times per second. So basically, it's a local oscillation. It's no moving anywhere.
Right, because like Tesla kind of denounced the electron.
Oh, no kidding. That's exactly my theory said. The electron does not exist. Oh my goodness.
That makes a lot of sense though, because that explains why electricity is so fast. When you start up a circuit, it's instant. You know, like it doesn't seem like there's any kind of latency that you would expect with a movement of something like a particle.
It's an electromagnetic wave.
Huh. Wow.
Wow.
And it oscillates, but it propagates in a specific direction, you said.
Oh no. Oh yeah, you're right. You know, so-called oscillate propagation. Of course, propagation along the wire, right?
Wow.
You know, if the wire connected with other two wires, you know what happens? All the particles oscillating propagates through this conducting material, just like an elastic. Elastic medium? You know, just
it really makes you rethink electricity. Huh.
Yeah.
Hey, you are exactly right. I try to kill this
does.
electricity, the concept of electricity, because they are all originated from magnetic pole, from a magnetic oscillation.
Right. Doctor, just for our audience tonight that doesn't know who you are, can you just kind of briefly describe who you work for and your educational background, and that, just to give our audience a little bit of depth on who you are?
Oh, thank you. Give me the opportunity to familiar with all the smart people. My name called Wei Ping Yu. I'm currently working at NASA. I have a PhD in engineering physics, and I work for NASA almost 20 years. I'm currently is called crewed spacecraft subsystem manager. So I do oversee Starliner. That's a Boeing's spacecraft, Starliner, and Dragon. That's a SpaceX Dragon. Our flight. Awesome. Okay, let me add one more thing. So the reason I met a gentleman like the organizer and also Bernie is I presented called Yuan theory of everything. It's a physical theory, and at the Tesla conference, and this theory basically simplify all the paradigm, all the worldviews. The universe is not made by dozens or even hundreds of elementary particles or multiple different forces, like 4 different forces. Those are wrong picture. I try to use my theory to say actually the universe made only by one single particle. Everybody knows is a magnetic particle. Do not believe anything come out the laboratory test. Say, hey, we tested this is called what is it called electron, and we discover neutron, we discover a proton, or even discover quarks. Anything come out from a laboratory, the so-called claim, nobody and no one else can cross-examine. Don't believe it. What I find is electron, proton, quarks does not exist whatsoever in this universe. So that's how the physics run to the core.
I couldn't agree more with you, Dr. Yu, and I think it's why we get along so well. And it's like the particle accelerator collider, like CERN, for instance. It's like they're taking the atom, which is like the smallest actual particle, and then they're smashing it to get like into pieces, and then they're thinking that, oh, these are all these new things, when it's like, no, that's just a shard, that's a fractal piece of the original thing, right? Like
exactly fragment piece.
Right, like you take a china, like a porcelain doll or something, you smash it on the ground, it's in 1,000 different pieces. It's like those aren't like characteristics of new things, they're just fragments of the original porcelain doll, and you're never going to figure out what the porcelain doll is by trying to find the shards and give them their own characteristics.
I totally agree.
Doctor, you could you explain a little bit more about your theory on the world is made out of one particle? Could you just like go a bit into that? Not too much, but as much as you want. Let's put it that way. As much as you want. I just want to understand how you're describing it, or how you're
Wonderful. This is the key question. If you understand, so that's how I started. I started with the universe, probably from the modern physics, find out there's a total, the foundation is corrupt. It's a totally wrong foundation. So what I did is try to find out. So what's the nature of light? So that's where I started was to find the nature of light. So I was thinking about, in order to understand what the light is, I have to understand what the smallest the particle is. So I try to find where can I find the smallest the particle. I found, okay, since the light particle, we suppose called the photon, right? So I find the light is actually not a particle, it's actually the wave motion, is the medium. So I would call you may call ether material moving, or I would call it's a magnetic medium vibrating. So that's a light wave is the wave carried by magnetic medium. So I said, okay, let's say assuming light particle is the smallest, right? However, the medium carry light. The medium carry light. So that means even orders smaller than photon particles. So I'm talking about the particle in the medium. So that's how I started. Okay, so now I started. What is the particle, smallest particle? Make up the medium. Anything you make up, anything has to be a real matter. So that's my belief. So without the matter, you do not talking about the wave. Wave means something carry on, have the carriers, right? So what material made the carrier? And I found out one and the only particle can make that one is a magnetic particle. So that's where I noticed, oh, magnetic particle, you know the light wave called the electromagnetic wave, right? So of course the wave, so that means the carrier has to be magnetic medium. So magnetic medium vibrating create the so-called electromagnetic wave. So that's what the light we see. So I said, okay, in order to make in order to carry light, we need a medium. And the medium, the particle made a medium, one and only is magnetic particle. So that the magnetic particle vibrating create the electromagnetic effect. So that from that point, I find out the smallest particle is a magnetic particle. But that's not enough. I hope you follow me, right?
Yes.
Oh yeah.
Okay, but that's not enough. My theory have another half. Not only magnetic particle is the smallest one, and I prove the only particle can exist in the universe is magnetic particle. So it's not just hey, magnetic particle is a smaller particle. You could have other particles, right? What I find, none of the other particle can exist. So I hope I can demonstrate to you. If you just give me 1 second, I'm gonna get a prop to demonstrate.
Absolutely.
Take your time. Take your time.
Yeah, to demonstrate that because this principle is so critical. If you understand this principle, you understand the entire universe, how universe operates. Bernie,
Wow, we look forward to it.
did I show you that one?
Yeah, this is amazing.
I'm not sure if you have yet, so I'm
I'm
stoked
gonna
for
get
this.
a prop.
Please do.
Okay, from my other room.
Okay, sounds good. And I absolutely love Dr. Yu's thesis, his science and the understanding of magnetism, and it aligns perfectly with my own model that I'm calling the VSPS fusion, or valence shell phase shift fusion. And it has to do with particles, atoms being made of the fundamental force of magnetic nuclear, and then that's be the original carrier wave force. And from that, you then have acoustic, which is your sound, which is your EM wave. And then you have photon as your light. And then you have ionized plasma as the fourth field. And that it's all just waves making the field that is supposedly solid.
They say virtual particles are positive and negative. And so that would
Virtual.
make sense if it's a magnetic particle. It has both.
Right,
That's a key
virtual particles. Like it's like there's some particles that like don't even exist, and then there's virtual particles, but it's like it's just a packet of mathematic numbers that are these virtual packets or particles, as they claim.
Okay, so I'm gonna use this prop to demonstrate that the goal is right. None of the other particle can exist. So this is a very strict demonstration. It has to be, so magnetic particle is a fundamental particle, and it is the only particle can exist. So this is a huge claim. If you believe this one, you will understand the whole universe, how they make it. So I use this is a positron, this is an electron, suppose to positive charge particle and the negative charge particle. So why I use this one? I use this as a counter example to demonstrate how ridiculous, how contradiction, if this particle exists. So let's assuming this is an electron. The same thing works for positron. So electron defined by called a negative charged particle. So this is electron defined as a carrying negative charge. Let's assuming that's true, and I will prove that's wrong. Okay. So how to do that one? So I said, okay, if this is an electron is a negative charge, hypothetically, let's split them into halves. Split them into halves. So what do I get? Bernie, can you give a guess?
You get. I don't know. Nothing, because it's. Or it's subtracting.
I thought that this is another tricky question, right? Just one particle, right? Negative charge particle. If we split it in half.
2 half particles.
Yeah. The most logical one is 2 negative particles. But somebody say, hey, can you split half and you get a 2 positive charge particle? That's gonna violate the charge conservation. We said the electric charge is conserved. So that means you cannot turn negative to positive, right? So that's
right.
conserved.
And two
Yeah.
negatives, they're going to repulse against each other, so you can't split it, right? That's where I was
That's
like, in my mind,
exactly the point. Bernie,
Yeah,
you got it.
Dipole.
So now, we cannot have a half negative, half positive. We cannot that either. Also violate the charge violation. So then Bernie said, okay, only left one choice, 2 negative charge particle. However, that's the problem. If you have a 2 negative charged particle, can you form or called recombine or unified into one original particle?
No.
No, you
If
shouldn't
it's
be
in
able to.
motion, if it's in motion, it will attract it. If it's the rotation, it's going really fast.
We'll
Right.
have
The
to be
other
off-
one could attract it.
But if not in motion, what if that?
I
Well,
don't know.
you couldn't do it because it's
they-
two
they
negatives.
repel.
Exactly. That's the contradiction. So if a negative charge particle assuming exists, then you hypothetically, you don't have the physical, you just hypothetically, hey, take a small parts of one. So what that small part of negative charge will carry charge? They say, oh, carry negative charge. So then how could the negative charge the particle and the negative to become a whole in the first place? If they couldn't, what that means? That means that this negative charge the particle assumption is wrong, so it cannot exist. So what it really is, now I try to say what it really is. So the purely positive charge particle, the same logic cannot exist. What it really is, every single particle has both negative and positive magnetic poles.
Right. So
They are inseparable. My goodness, you. So hey, the host. I could not see your name. What's your name?
Mike.
Oh, Mike. Okay.
Yeah.
You got it. So that means. So now let's think about the significance. The lady, you asked the most fundamental questions. I hope, based on this demonstration, you understand. I hope audience understand the one things is the so-called purely negative charge particle or purely positive charge particle cannot exist because it violated Coulomb's law, like charge repel.
Right.
Okay.
Yeah.
So once you got that one, now let's see what's the significance. If every single particle is a magnetic particle, if every single particle is a magnetic particle, can magnetic particle orbit another magnet? So that means I try to say how ridiculous this atomic model, we call the orbital model with the electron orbiting the center of the nucleus. That model is completely wrong. Okay. So I try to explain why that model is completely wrong. Because electron, so-called negative charge particle, does not exist. And so positron does not exist. And quarks does not exist. Quarks, you carry a single charge, right? So quarks does not. So that means all these particles does not even exist. So what exists is the so-called proton and neutrons. They're all made by magnetic particle. So that means the so-called nucleus is just magnets.
Right.
Now let's see.
So
yeah, you got it.
Would it be a coherent field of energy?
Exactly. Coherent means they all naturally binding together. Coherent. So that's exactly what atom is. Atom is the most stable structure because all the particles are made of atom are coherent together. It's magnetic attract together. So that's why atom is the most stable structure. I hope this makes sense. Yeah. If you get this one, you know we have to rewrite all the atomic model. We have to rewrite it. Every time you made the electron, you reference electron. So electrons so-called flow in the wire does not exist. There's no part in atom have any flow. So there's no such particle exists in atom in motion. It's all magnetic combined. There's nothing in motion. So
How
what?
is,
So okay, go ahead.
How is your peers at work feel about
Oh.
your theory?
Great questions. I spoke to once we have I formed a group called Kennedy Space Center Fundamental Physics Research. A lot of physics and also other engineers. After they listened to my talk, I believe that was in the 2013. Right? I almost converted all of them. So if you use your own logic, you will understand. So the so-called electron was made up, and that mistake was created by J.J. Thomson,
Right.
smart British physicist, right? Experimental physicist. J.J. Thomson did called Castle Ray test, and find out, oh my goodness. So he named the phenomena. Say magnets can bending the lights inside of a vacuum tube, right? So he explained that phenomena as a electrical phenomena. So he defined the particles made up of the lines, those electrons, and the next charge electron. That's a mistake he made.
Yeah, it's kind of a misrepresentation of the actual phenomena itself.
Exactly. I don't have to explain more. Yeah.
And can you make the link with that and the quarks?
Oh, make the link to quarks. Is that right?
Yeah. Can you? Is there anything similar with that type of particle with the quarks?
Oh, sure. If you think about it, if we define quark as a negative charged or positive charged particle, fraction charged particle, that does not exist. The so-called quark are smaller fragment of magnets. Bernie is talking about we are particle accelerator impact. You got smaller fragments, but smaller fragments is also magnets. One thing about also why is this so wonderful about the magnets? Magnets is the only particle you can subdivide it and still remain the same property. So you divide a magnet, you break a magnet, you got the two smaller pieces of magnets itself. So magnetic particle is self-similar. It's the only self-similar particles.
Right. I have a question for you. A magnet, just a regular magnet, bar magnet. What makes that magnet keep its charge and never dissipate?
Wow, you ask very deep. These are the questions that I do not believe anybody solved this one yet. But let me give you my answer. First, smallest magnet. So I defined the smallest magnets called universal fundamental particle. Small, just smallest magnets. Yeah, as a natural born and carry charge eternally carry charge. So that's the natural born matter.
So it's like perpetual, I guess you could say.
The effect where we have a perpetual effect, but as a fundamental particle, I believe this is a fundamental form of matter. So every single matter. This is a good question, because if the fundamental form is not a magnet particle, what happens? Charged particle, I just say, cannot exist. So what about a neutral particle? People say, hey, can you have a neutral particles exist? I said, you cannot. Assuming this is a neutral particle. If this is a neutral particle, how can you form a bigger particle with a basic neutral particle? Neutral particle does not we assuming have a zero electromagnetic force, right? But people say, can neutral particle have a gravity? Let me tell you, cannot.
No.
Or or you can assume they have gravity, but gravity is zero. How do you say that one? Because if I use this one as the smaller unit of magnets, the same unit has gravity, assuming that it has gravity. So that gravity equals to 0.36 power. So that means point have 36 zeros afterwards, and then 1. So that's the strength of gravity. So that strength will not hold any two particles together. So that means if you have a neutral particle never can combine to a particle we are see. All the particles we see are combined with electromagnetic force. Without that force, particle like a two grain of sand, you cannot put the 2 grain sand stick together.
Right.
Yeah. So that means those kind of matter we will never be able to see.
Interesting. Yeah, because I've asked that question to a few people, how a magnet works, and a lot of people can't answer that question. You know, how does it hold that magnetic charge in it?
I have another discovery, but I'm not even sure I wanted to disclose about how magnets works. Yeah.
Well, magnets.
How magnets work. So what is magnetic force? How can magnets work over distance?
Yeah.
The magnetic force and the gravity has something in common. They both have energy, and the force is actually the energy differential. So
where you have energy, where have a differential, why two magnets has to repel or has to attract? That's
all. I'm just saying a force is the energy differential. If they attract or they repel, it's a mathematics thing, but based on that. But you know, the gravity is a gravitoelectric energy.
So I see it as gravity is an effect, and that magnetism's like the only fundamental force that everything else is built off of, depending on the motion vector of it.
Right.
And that from there, it's like then you get electric, and then you get gravity from them. So it's that's a triple dimensional vector effect rather than the force. And the force is, I guess, the distance of energy between them that you'd have.
Yeah, exactly. And the force is actually, I think it's a secondary effect from the difference in time dilation. From point A and point B, they have different time dilation, and that creates a different force.
Do magnets work in space?
Yes. That's a great question. She basically thinks if magnets depends on matter, right?
Well, no, I'm thinking
space may not work, right?
Well, I'm thinking if a magnet it has to do with like with our physics and the rotation of the Earth and the spin vectors, then what if it's in space? Would it work in space?
So you basically say magnetism. You are talking about you are citing the same as a traditional theory. Say magnetism is an effect of a motion of an electron or charge, right? Yeah.
Mm-hmm.
So you agree with that? I believe that statement is completely opposite. This is wrong. Opposite, actually, all the electric effect is produced by magnetic poles.
Right, and that magnetism is essentially inductive and cold and endothermic, and then electric effect is the hot radiation coming out.
Oh, radiation is not an emission particle, is not come in and come out. Radiation is a vibration of, say, electron, right? Create oscillation, and the oscillation transferred through this ether medium. So you may say, hey, the radiation just a vibration of ether, or I call the ion medium, because I believe the ether is made by smaller particles of magnetic particles.
Yeah, virtual particles, which is energy.
Oh, I would not use a virtual. Virtual means hypothetical.
Right?
I'm using
Virtual
real
non
particle. Yeah.
I want to just quickly interject. Like my understanding of the current model, mainstream model, where they say virtual particle, it's like, well, one, virtual means non-existent, but they believe it is, or dark matter, whatever the heck. But it's just it's a packet or a certain amount of energy, a
Yeah,
specific
energy.
number of energy that transfers in that interaction, right? So they're calling it a particle, but really it's just they're missing how that energy is actually transferring between one to the other and not
Yeah.
actually
Yes.
a particle.
See
Energy density.
what I
Yeah,
know, like a
exactly.
virtual particle, it exists, but they don't know the charge until it interacts with the other one. Then they'll know if it's a positive or a negative. So it's a space of energy, but we don't know the charge yet until it interacts with the next one. Then we know
Yeah,
if it
that's
was a
how we
positive or a
detect.
negative.
It's a relative. Yeah. How we detect the what the polarity. Yeah. But the word virtual give people like a hypothetical is some kind of non physical tone.
Yeah,
Yeah.
it's kind of a wrong terminology to use.
Well, it's kind of correct too, because it's like there's no actual particle there. It's just an energy exchange, and it's these
It's a coherent
accurate
field of
energies.
energy.
Yeah.
Yeah. So motion, vibration wave. Yeah.
Awesome.
And then how it interacts with each other, and it's the magnetism is the coherent carrier wave, and then you have the standing waves of light, of electricity, and of ionization being plasma, which then creates the field. And once you have a plasma field, you have a stable particle, is how I see it.
Yeah, that's funny. It's a good timing because that's exactly what I'm showing with the free fall experiment. That the magnetic field of the neodymium ball creates an acceleration vector that is being added to the gravitational acceleration. So that's why one ball is faster than the other one because it has one more acceleration vector that adds to the net acceleration. So it's funny. It's a strange timing that we're talking about that.
Yeah,
So
exactly. And we have the
Synchronicity, I'd say.
best guest to come on and talk about magnetism.
yeah, and I was. Did you see my free fall experiment right before your talk, doctor?
Mm-hmm.
Yeah. Okay.
You see, okay.
I mean,
Or if you want to show it
So
again, you
yeah,
can show
maybe
it again.
quickly show it again. So it's what
Yeah.
Phil was just doing, his experiments with dropping the magnetism.
oh, you have something
Yeah.
Yeah,
new
Phil just did it.
phenomena
Here
I
we
would
go.
like to see.
So I have a magnetic ball. I have a neodymium ball on the left, which is the red circle, and on the right it's a chrome steel ball, and
Okay.
they're both held against gravity using electromagnets. And when I cut off the current, the balls are falling down exactly at the same time,
Uh-huh.
simultaneously. And you'll see what happens. Remember, the red circle is the neodymium ball, and the turquoise circle is the chrome steel ball.
Okay, I can give you a prediction before you do the test. The
Okay,
magnetic balls fall slower.
slower.
Yeah.
Okay, so I'm gonna restart. So now, one sec. Okay, so now the balls are starting exactly at the same
Yeah,
time,
same
the same
time. Yeah,
place.
let's see. Yeah. The free fall experiment.
And actually, the red, the
Red seems
neodymium ball
started
is
first.
accelerating
Yeah.
faster.
Yeah.
So they're not they have the same weight. That is, by the way, the weight is almost the same, so it makes no difference. But
Shape, size, shape the same.
yeah, so you can see that the red is winning the race here.
Yeah.
Clearly.
So if you redo this one with a higher difference, you will get a different. I believe you will get it. Oh, okay. So yours is slightly different than experiment made by a Lockheed Martin scientist. Okay.
Yeah,
Right.
yeah. Pretty
Okay.
much
Okay.
pretty the same.
I see. I see
Boyd
the difference.
Bushman.
Yes,
Boyd Bushman.
you're right.
Yeah, but I think it depends on the phase because the neodymium ball either it the pole faces the ceiling or the floor. I think it depends.
You are right.
It's gonna make the acceleration different.
Make an acceleration because the one thing. So let me see. My predictions are wrong because I was thinking about a Lockheed Martin scientist the experiment.
Yeah, Boyd Bushman.
Yeah, Boyd
Boyd
Bushman.
Bushman.
Oh my goodness, you all know that one. But your test is different. So his test is force two like pole together, right? Force two like pole to get tied together. So create like a 3 feet each side. So totally 6 feet side of repulsive, field. And your experiment is just one dipolar magnet. So what happens is the Earth, our gravity is a magnetic force. So what happens is they adjust it to opposite pole. So Earth's pull magnets faster than non-magnetic particle. So that's why I drop fast. So I was wrong, and now I know why wrong because I was thinking about Bush and the Bush
Boyd
and
Bushman.
this make more sense.
Yeah.
Than that one.
Because when Boyd Bushman did it, he had two opposing magnets and he had
Right.
a hole in both magnets and he pushed them together.
Force them together. Yeah.
Right. Created this field around it.
He said that's
And
like
then
a 3 feet each side, right?
Yeah, 3 feet.
Totally
Yeah.
like 6 foot diameter.
Right.
So that
he-
that create what is the diamagnetic effect, dropping.
Diamagnetic field.
Yeah. So that means that's actually for me it prove one thing, prove existence of ether. So the
Right.
ether is a magnetic medium.
Yeah.
So that force interact with magnetic medium. So that's why slow down, right?
Now, question is for you is as that magnet is falling, the one that Boyd Bushman did, was it creating eddy current relative to the ether?
Yes, of course. This is of course. When you have a moving magnet around the conducting material, create the ether. I'm sorry, create a current.
Right.
That's you
Interesting.
call it eddy current. Yeah.
Wow.
Yeah. So
That's cool.
it's really a historical show tonight. No, not everybody. It's great that you are open-minded, doctor, because not all doctors are very open-minded.
Thank you. I hope you can do the same test as a Bushman, yeah, and also perform single magnets. I fall trap to your single magnets, yeah, because I was thinking about Bushman, that test.
Yeah, Bushman's.
So
Yeah.
actually, if you produce this test simultaneously, that would be a good education experiment. So I
Yeah.
probably were stealing your idea for
Yeah,
my
Boyd Bushman actually did write a paper on it. He published it in 1996 at Lockheed Martin. So you might want to check into that. It's probably still online. You can check that out. I haven't looked into it in a while. It's been a while since I've seen the video. But he also did an interesting one with a coil of wire and hooked it up basically to the mains of the house. And it rose off the ground and just boom, like a magnetic levitation.
Yeah, sure.
The only problem with that is if you leave the power on too long, the coil burns up.
Right. You need to generate a lot of high voltage power. Right. Yeah. So I try to make some called a hover graph.
Right.
Need high voltage, minimum of 15,000 volts or something,
Wow.
and actually burned those supporting stuff, spark.
Now,
I know. Yeah.
now, if you're dealing with that high voltage, do we have to worry about the radiation coming off that? Is
Yes.
there radiation factor there? So that would be another issue. One thing to make it actually work, but is it actually safe to actually be around it? And that's what they're saying about some of these UFOs. People get really close to them, they get radiation burns.
Exactly. That's what I believe. So they are powered by anti-gravity, actually due to anti-gravity, that's an electromagnetic wave opposite to gravitational polarity. So that's why can make them instantly acceleration almost, right? Yeah, repel.
Right.
Yeah, positive. Yes, I
I
do
can't
believe.
imagine. I can't imagine the amount of force that's involved in that. Must be enormous to create that effect. And one thing, be around it when that's happening cannot be good for you. So to make a craft like that, you would have a device where you have to shield yourself greatly to be even around that field.
Yes, yes.
Oh, exactly. It's why I have not produced or conducted like probably 100 different experiments that I'm planning on of like increasing magnitude by combining uh, more voltage. So then I get a plasma arc into my electrolysis reactor, or putting in the acoustic sound waves into that for the sonoluminescence aspect, right? Where you when you combine certain thresholds of magnitudes of energy into it, you're going to then have these exponential gains in energy interactions as the outcome as well. And that's why so many people struggle with believing my claims with hydrogen and electrolysis and stuff, because they're like, how have you not blown yourself up, Bernie? Or with specific aspects of transmutation within the electrolysis reactors. That it's like I did it once when I was first messing around, and sure enough, there was radioactive parts that formed, and I got very sick very quickly. And then I realized what was going on. And then since then, over the last 15 years, I've never crossed those thresholds again until I have the safe space, the safe lab to do it, and to risk contamination, to be able to be shielded from radiation, or well ventilated, where I go over 5 volts of electricity in myself running electrolysis reactors, and put in maybe 15,000, and all of a sudden the room would blow up from the amount of hydrogen that's coming out of it, as opposed to just small little amounts that are able to evaporate into the air.
Yep, exactly. There was some experiments that I did with the Don Smith device, dealing with
Then
high
you stop.
voltage and coils and stuff like that, and spark gaps. I kind of backed away from it because at that
You're
time I didn't have a
experiencing time dilation, which has time radiation effects, and that's the
yeah,
thing, that there is what should be called essentially time radiation, or it's the
yeah,
differential when you're having time. I
It's
guess
not the problem is not
messing.
the problem is not time radiation. The problem is the frequency is too high. You're gonna have a side effect, which is high time dilation as well, coming up with it. But the real problem is the high frequency in the first place that creates the radiation. You know what I mean?
yeah,
Time dilation is very safe,
yeah.
but
Like
the
when I did my experiments, whether it was digital or analog, the time was slowing down. when I did my experiments.
Yeah, that's
And
cool.
how I did it was I had two very strong neodymium magnets, north poles facing out, spinning on a shaft, okay, at about 4,000 RPM, and I was hitting it with 11,000 volts. And when I did that, my clock started changing.
Yeah, yeah, that's cool.
Yeah. It didn't
Yeah.
matter if it was analog or digital, they all started changing.
Great
Went out of
Scott.
whack.
That's what I have to say.
See, my question with
Versus,
time dilation is when we conduct these experiments, what happens to the outside world in comparison to, our time zone? How does it reconciliate?
Well,
It's
you're gonna
That's what
see
I'm
the outside
talking about.
world on fast forward, and
no.
But
the
but
outside
on
world will see you
physical,
in slow motion.
the
Okay, I'll
biological physical aspect of matter, that's where I'm talking about there being this time radiation aspects of it, that when you're essentially engineering, ripping apart space-time, the fabric of space-time itself to get through one to the other, that as the rest of the space has to catch up with the time that you've gone through or maneuvered, that it does a bit of decay or addition, I guess, growth into the matter around it.
Okay, hypothetically, you conduct this experiment and then you go to your work. Do you incur traffic to, take the time for everybody else to catch up? Or are you faster in space and time and the universe doesn't and you get there?
It's like in the Matrix. Remember the movie The Matrix, when he slows down time and then he dodges bullets and things like that. It's
Mm-hmm.
actually the same thing. You know,
Okay.
you perceive the external world either in slow motion or in fast forward, and the external world will perceive you exactly the opposite.
So
yeah,
question, like
that
let's say we have a clock though, and our local clocks, is ticking this way. What is the, surrounding clock? What would that be? Like how does that reconciliate at one
universal
point?
time.
Okay.
Yeah. Universal time. See, the experiment I did, Doctor, was based on Dr. Bruce De Palma. He was a MIT professor, and he was spinning magnets like my experiment. And when he put the clock on the axle, just above the axle of the spinning magnets, the clock starts slowing down.
Mm.
So he's actually a doctor himself. He's a former MIT professor back in the 75 time frame, 1975. And he built the first device, I believe, around 1979 and proved by spinning magnets. And if you put the clock above the shaft of the spinning magnet, time slows down. So he was seeing a fluctuation of time dilation there just by spinning a magnetic field at a very high RPM. So I don't know
Yeah,
if
so
you have any comments.
you already have the energy of the magnetic field, and you add gravito-electromagnetic energy to that, so it all contributes to the time dilation.
So, Doctor, what do you think about that experiment that Bruce De Palma did on the spinning magnets? Do you have any comments on that?
Or time dilation in general.
Oh, I do not familiar that spinning magnets. Actually, I actually do not believe time dilation, length contraction, and the mass inflation. I believe that's the mistake
Yeah,
made.
I agree with you that length contraction and mass increase is nonsense. They were never proven,
Right.
but time dilation is. I think
Is
it
some
makes more
more.
sense.
Yeah. So my question is, you said the spinning magnets.
Right.
So how do you
So-
know time slowed? Is that because the clock slowed down?
Yeah, the clock was slowing
Oh,
down.
okay. So that's a physical because of magnetism add extra, changing the material property mechanism. So that's why mechanical clock will be impacted. But that's not due to time dilation due to relativity effect. That's not a relativity. That's just like a gravity. You add a different height, gravity you clock running at a different time. That's because of gravity is just like a magnetic. Gravity is magnetism. Okay, in my theory.
Yeah.
So that's why you said the spinning mechanism will impact all the functions, materials surrounding it, including biological beings.
Yeah, my note is gravity because force is a energy differential. It's very simple. Same thing.
I hope I answered your questions, right?
Yeah,
I
that's
believe a
great,
clock.
Doctor.
Yeah, clock impact.
Yeah.
Not a real
Well-
time impact.
We're at the top of the hour. Thanks a lot, Dr. Yu, for coming on and our whole panel. We go live to air again every Friday at 9 o'clock Eastern, 6 o'clock Pacific. And again, any questions, comments for the panel, you have Bernie's email address. You have my email address. You can make comments on the YouTube channel, Faraday Research, and also Bernie at Crypto Alchemist. And we'll see everybody next week.
And if you want to
Cheers.
stay around for a minute, Dr. You, after we're live to talk, feel free.
Okay, sure. I can
no
stay on a little bit
Okay.
longer.
Thanks a lot, everybody.
Thank you, Mike. Thank
Cheers.
you.
Awesome. Thanks.